For this lesson, we are looking at the nomenclature for covalent compounds. So we're looking over here. Is there a metal present? No. Covalent molecules, we are looking at non-carbon based, right? And we're looking at this section today. So where we are looking at binary, so two, like a bicycle, binary inorganic compounds that are both non-metals. So when we're naming these binary molecular compounds, meaning two different non-metals, it is really important when looking at this compound. For example, this one given is Cl2O7. We would look at this and go, chlorine. Chlorine is not a metal. Also, there is chlorine here and oxygen. So there are two elements, so it's binary. They are both nonmetals. So we're using these rules to name it. So first, we're going to name this first element, we're going to name it. So we're going to write down here, we've got chlorine. And then we need to use a prefix if two or more atoms are present. So we can see here that there are two chlorines. So I need to use this chart here, mono, di, tri, tetra, pent, hex, hept, oct, non, and dec for the prefixes. Well, there's two chlorines, so I need to say dichlorine for two chlorines. Two chlorines, this tells me. Then, for the second element here, replace the stem of the element's name with "ide." So we know oxygen turns to oxide. But again, we need to use a prefix to tell me how many oxides. Well, there is 7. So looking at my little chart here, 7 means hepta. So I'm just going to say, so it's dichlorine, and then I'm going to say hept oxide. Heptaoxide. So dichlorine means Cl2, two chlorines. Heptaoxide means 7 oxygens, O7. And that's it. Now, the only time we do not use a prefix is if there is one of the first element. If there's one of the second one, you have to use a prefix. Like, for example, CO. If there's one of the first element, yes, I do not say mono. I'm just going to call this C is carbon. I'm not saying dicarbon. There's not two carbons. I'm not saying tricarbon. There's not 3. There's 1 carbon, and I'm not going to say mono. It's just carbon. However, how many O's are there? There's 1. You do need to say one of the second element. So I would say carbon, and then I would say carbon monoxide. So this tells me, just by saying carbon, I know that there is one of them. And then I look at this and I go, oh, oxide. Oxide means oxygen. Mono, there's one of those as well. So it's just CO. All right, let's look at another example. NO. So we would look at this and go, oh, that is not a metal. Nope, nitrogen is a nonmetal, oxygen is a nonmetal. Okay, this is a covalent compound. We need to use prefixes. So how many N's are there? There's 1 N and there's 1 O. No prefix here. I'm just going to say nitrogen. And then I do need to use a prefix. And so I would say mono, and oxygen becomes oxide. So nitrogen monoxide. All right. Again, we would look at S and say, oh, that's a nonmetal, and Cl is a nonmetal. Okay, we need to use prefixes. How many S's? 2 S's and 2 chlorines. So disulfur. 2 chlorides would be dichloride. Gets to be a mouthful, that's for sure. Okay, writing them is a little bit easier. Dinitrogen. Well, I can look at this and I can say, oh, well, nitrogen is N. How many nitrogens? That tells me right there is 2. Monoxide. So we know oxide is oxygen. How many oxygens? Mono, that just means 1. So it's just N2O. And finally, we have dihydrogen. So again, we know that hydrogen is H. Di tells me that I have 2 H's. Oxide is O, and it tells me mono that there's just 1. So H2O. Okay, so it is good to know here the 7 naturally occurring diatomic molecules. We've talked about that before is Brinkelhoff, right? Bromine, iodine, nitrogen, chlorine, Brinkel, and then Hoff. So 1, 2, 3, 4, 5, 6, 7. 7 naturally. So in Brinkelhoff, all of these are diatomic molecules. We just call them their elemental name. So H2 is just hydrogen. We don't call that dihydrogen. Same with nitrogen, oxygen, all of the rest of them. We just call them their elemental name. Same with some simple covalent compounds like H2O, we call it water. We don't actually, I mean, this is, yes, it's scientific name, dihydrogen monoxide, but for common names rather than the systematic names are okay. NH3 is ammonia. Its systematic name would be nitrogen trihydride for ammonia. And same with H2O2, that common name is hydrogen peroxide. Again, its scientific name would be dihydrogen dioxide. And another one is CH4, which is methane. Again, its scientific name would be carbon tetrahydride. So that is also fine. Okay, so now let's look at acids. Now, acids start with hydrogen, and then they end with either a nonmetal or a polyatomic ion. So there are binary acids like these two. Binary, remember, means 2. So I've got hydrogen, which a nonmetal. Chlorine is a nonmetal. So I have, notice that all of these start with H. Acids start with hydrogen. They're molecular compounds because all the bonds are covalent. And you should memorize these 4 strong acids. So if it is a binary acid, like these two, HCl is called hydrochloric acid. So we have hydrogen, that's where the hydro comes from. Chlorine becomes chloric, hydrochloric, and because it starts with an H, we end with acid, hydrochloric acid. This HBr, similarly, hydrobromic acid. And then these last two, H2SO4. So we would name, and we don't say hydro with these. These are polyatomic ions, if you remember from the last lecture. SO4 is sulfate. Well, when it's in an acid form, we change it to ic. So this nitrate, we change it to ic when it's with an acid, when it is with an H. So we would call this sulfuric acid, not sulfate. This SO4, when it was an anion, was sulfate, but when it's with hydrogen and it forms an acid, it becomes sulfuric acid. And HNO3 is nitric acid.